you can see, designing and building an airplane takes an awful lot of work, and among that it takes some problem-solving strategies. Now that means you've got to be able to identify and understand just what the question or problem is so you can begin to investigate it. Right now you're going to meet some of today's researchers who are involved in the shapes of flight. As you meet this research team, consider the role of mathematics and mathematical tools in scientific inquiry, the value of collaborations and teamwork in conducting research, and the engineering process and its application in everyday life. The leader of this design team is Mike Logan.
Airplane design is a team effort. Like any good team, every job is important. As project engineer, it's my job to shepherd the aircraft through its stages in the life cycle. To define the problem, let's look at a current challenge. 20 years from now, NASA wants an airplane that will carry twice as many passengers as today's airliners and transport them to their destination at half the cost. That's a big challenge, especially when you consider that the airplanes of the future will have to be quieter, safer, more fuel efficient, and more environmentally friendly. The next step in the process, then, is to propose solutions. This is Paul Gelhausen. He's one of our designers on our team. Paul, why don't you talk about one of the solutions you're working on?
Well, the solution that's up here is the blended wing body concept. It's a radical change from the 747 type airplane, which is a tube with wings. We've gotten rid of the bumps and some of the bulges that are on the traditional airplane that has a glide ratio of about 18, and put them into a much more clean aerodynamic shape that will have a glide ratio of 23, we hope.
Thanks, Paul. Step 3 in the engineering problem-solving method is to analyze and evaluate solutions. To do that in the airplane world, we think about the 4 basic forces on an airplane: lift, drag, thrust, and weight. Those 4 forces have to be in balance for the airplane to work. To do that, we turn to experts in the field. This is Karen Deere. She's one of our nozzle researchers that helps us look at thrust. Karen, why don't you talk about what a nozzle researcher does?
I design and research nozzle concepts to determine which is the best candidate for generating thrust for an airplane. Sir Isaac Newton's third principle, which states for every action there's an equal and opposite reaction, helps us understand thrust. If we use a balloon to demonstrate this, we allow the air inside the balloon to escape through the opening. We see the motion of the balloon in the opposite direction. A nozzle can be compared to the opening of a balloon. Changing the size changes the amount of thrust generated. Nozzles have different shapes, just like airplanes have different shapes. There's always trade-offs in the design process.
There certainly are, Karen. In fact, one of the trade-offs that we look at is the cost required to achieve the capability that we want to have. Sharon Jones is one of the people that helps evaluate these concepts from a cost standpoint. Sharon, why don't you talk a little bit about that?
Well, Mike, what we do is we create a model of the aircraft on the computer so that way we can go in and change different aspects of the aircraft. We can look at what type of materials are we going to use, how big is the aircraft going to be, how many passengers will it carry, and also how much it's going to cost for the airlines to operate the aircraft.
Thanks, Sharon. The last step in the process is to select and refine the solution. We'll take a look at that in a moment, but first let's check in with Shelley and Van, where he's getting his own lesson on the balance of the 4 forces of flight.
I'm getting suited up in my hang glider outfit thing here, and yeah, alrighty. I'm gonna get hooked up here, getting ready for my first flight, and I guess we'll catch y'all later. Back to you, Shelley.
Well, it looks like Van is getting some final instructions before he's going to find himself airborne. And me, I'm going to change my clothes and I'll meet you back at the Connect studio. And you guys, I'm sending you first on a final check, and I'm going to send you to check out the most powerful tool used by aeronautical engineers when they're doing their investigations. That tool, the wind tunnel, such as those found at NASA Langley Research Center in Hampton, Virginia.